In this video, we're going to be looking at how to find the domain and range of composite functions. And a composite function is something like this, g of f of x. So we have two separately defined functions, f and g of x, and f of x in this case is a linear equation, linear function, whereas g of x is a square root function. And so they look like very different graphs. We know that lines look like this, and we know that square root graphs either look like this, or they can look like this, etc. So if we want to find the domain and range of f of g of x, what a lot of people will do is they'll first try to work out the expression, or what the function g of f of x looks like. And we can work that out, but just a heads up, this will not help you work out the domain and range of g of f of x. So what I'm going to do is just substitute f of x into g of x. That's what g of f of x means. So this would be the same thing as the square root of x plus 4. And the way I work that out is we're literally just subbing in x plus 4 in for x. So if I replace this x with x plus 4, I get g of f of x. Now what a lot of people will think is, in order to work out the domain and range of g of f of x, or what I just worked out here, all we need to do is work out the domain and range of this right here. And that's very incorrect. You cannot do that. What you actually need to do, and what I personally do, is I draw a function machine. It seems very corny, but I still do it to this day. So if we're talking about g of f of x, that simply means that all the values that we put in, like 1, 2, 3, like any integer, they first go into x here, and that's f of x. So all the values we input into this machine, they first go into f of x, then the output from those f of x functions will go into g of x. If that didn't make sense, I'll explain that in a sec. So f of x is this, and then all the values from here go into g of x. And so now what I'm going to do is I'm just going to write the domain and the range of my functions here and here. So if we have a look at f of x, the domain of f of x is an element of all real numbers, and the range of f of x is y is an element of all real numbers. And I'll do the same thing with g of x. G of x, the domain, is x is more than or equal to 0, and the range is y is more than or equal to 0. So first I draw this machine. In order to solve or find what the domain of g of f of x is, we need to make sure that the range of f is a subset of the domain of g. So what does that mean? If we have a look over here, the exit of f of x, the output values of f of x, and the input value of f of x, what we need to make sure is that all the values that are allowed to leave the f of x machine are able to enter the g of x machine. So let's have a look here. YER means any real number can exit the function f of x. That can be -1, +1, -1000, +1000, anything. So we need to see if those numbers here are allowed to enter the g of x machine. So if I were to have, let's say, 1 leave the first machine, is that allowed to enter the second machine, the g of x machine? Well, yes, it is allowed to, because any value where it's more than 0, we're saying it's allowed to enter this machine here. So 1 is allowed to enter this machine. But what about, let's say, -5? We know that because the range of f of x is any real number, we can say that -5 is allowed and will leave this function. But is -5 allowed to walk on over into the g of x machine and try to enter it? Well, no, because the only values that are allowed to enter this machine are any values more than 0. So in this case, I would say that the range of f of x is not a subset of the domain of g. So what does that mean for the domain then? Well, in order to work out what the domain is, we need to restrict the range of f of x. And the reason we're saying that is because we don't want any values to leave the first machine that isn't even allowed to go into the second machine. We want every value that leaves the first machine to be able to go into the second machine. So if I were to rewrite the statement, the way I would work out the domain is I would say that the range of f of x, that has to be more than or equal to 0. Why does that have to be more than or equal to 0? Because any value that leaves this, if it's more than or equal to 0, we're saying that those values are happily allowed to go into the second machine. So the range of f of x has to be more than 0. And another way of talking about that is just simply saying f of x has to be more than 0. Now we're just having to solve an inequality where f of x is just x plus 4. So if x plus 4 has to be more than or equal to 0, we can solve this function and say that x has to be more than or equal to minus 4. So we started off with a domain of all real numbers being able to enter this machine. So any integer, any real number is allowed to enter this machine, and we pretended like everything was okay. But we realized there was a little situation over here where not all the numbers that leave the first machine were allowed to enter the second one. So we're saying we want to restrict the number of numbers that leave the first machine by restricting the domain. So we're restricting the domain to simply x is more than or equal to minus 4. So now that we have this situation here, we need to work out the range. The range we can only do graphically. Remember this. If you wanted to work out the domain of a function, you can by all means do that algebraically. However, if you wanted to find the range of a function, you must always use a graph. You must always do it graphically. So let's have a look here. We need to graph the output machine. The output machine is g of x. And the reason we're doing that is we want to see what values leave the machine altogether. This is one machine in unison, but we have two individual ones. So we're going to have a look at the second function over here and try to draw the graph of that. The graph of g of x is the square root of x. So we're simply going to draw a small graph for what g of x looks like. It's a very rough graph, but the graph of the square root of x looks something like this. Something like this. And we need to now look whether our range has been cut off from the domain. Because we changed only the range over here, we changed the range of numbers that can leave the first machine, the numbers that were allowed to enter the second machine were completely unaffected. So our domain and the range of our second graph, i.e. the range of the whole machine, it'll remain completely the same. So if that doesn't make sense, we'll go through another example in a bit. But what that means is that the range of the whole function is y is more than or equal to 0. So let's have a look at another example. So we're going to have a look at this example here. Part A to this question will generally be work out f of g of x or g of f of x. Work out the expression for it. So again, in order to work out what f of g of x is, we simply substitute the function g of x into f of x. So what that will look like is, instead of working out what f of x is, we're going to work out what f of 2 to the power of x is. So we just simply replace the x in f with g of x. So that's the same thing as 2 times 2 to the power of x, take 4. And using your index laws, we know that we can actually simplify this, because another way of writing 2 is 2 to the power of 1. And we know when we do a base to the power of an integer times by another base with the power of an integer, we can simply add the integers together. So we know we can do 2 to the power of x plus 1 take 4. So that is f of g of x, also known as fog of x. Now, that was well and truly good, but this is really irrelevant if we're trying to work out the domain and range of f of g of x. So in order to work out the domain and range, I'm going to draw my number machine. Now, think about it this way. If we want to work out the domain and range of f of g of x, we know that whatever x value we put into here, they first go through the g of x machine. And if they go through the g of x machine, whatever numbers come out of this machine, or whatever numbers are the outputs of this function, they go into f of x. So that's how I'm going to draw this setup over here. Next, I'm going to draw the domain and range of each of these functions. And because f of x is a linear function, I'm going to draw that x, er, i.e. all real numbers, are the domain of f of x, and the range of f of x is that y is an element of real numbers, i.e. all real numbers. Now if we have a look at the graph for g of x, in case you're unaware of what the domain and range of that graph would be, the graph of exponentials, they have an asymptote at y equals to 0, and they will climb exponentially like such. And because this is the graph of y equals to the power of x, we can see the domain and range. The domain is that any real number can be entered into this function. So we know the domain is simply x is an element of all real numbers. But looking at the graph, because we know range has to be done graphically, the range can be only any value where y is more than 0. So it cannot even equal 0 because of this asymptote. So I'm just going to say y is more than 0. So now that I have this, we're going to work out the domain and range of this function. In order to do that, we need to make sure that any number that leaves the first machine is allowed to go into the second machine. So let's think of any number more than y being more than 0. Let's think of any number more than 0. Let's say 6. If 6 was to leave the first function, i.e. 6 was an output of g of x, can 6 enter the second function f of x? Well, yes, any number can enter f of x if it's a real number. And we don't even need to check for another number. We know that any number where y is more than 0 is allowed to enter the second machine. And so the way we write that mathematically is that the range of g of x is a subset of the domain of f. So if we have a situation where the range of the first machine or first function is a subset of the domain of the second function, we know that the domain of the whole thing, f of g of s, is simply just the domain of the inside function, g of x. And because we know the domain of g of x is all real numbers, then the domain of g of f of x is simply all real numbers. Now let's have a look at what the range would be. In order to work out what the range would be, it's a little bit more complicated. Again, we need a graph of f of x. So I'm going to draw the graph of f of x, and luckily in this case, it's simply just a line. So axes and y equals to 2x take 4, I'm going to draw it roughly, will look something like this. Not to scale. So let's have a look at what this means. So any number that leaves the first machine is going to be entered into the second machine. But as we can see, only the numbers that are more than 0 actually enter the second machine. So the input of the second function being x, we know that only the numbers where x is actually more than 0 are entering. because those are the numbers that leave the first machine. So because all numbers more than 0 are entering this machine here, any number less than 0 we know is not going to be an input. So I'm going to just simply cross that out on my graph. So any number that is x less than 0, because we know those numbers aren't even entering the machine. So now we can look at what the range is. We know that the coordinates of this point here, which is the y-intercept, is going to be 0, -4. And as we can see by the graph is displaying y values that are more than -4. So judging from this graph, we've just worked out our range. The range of the whole thing, f of g of x, we know this is simply just the range of this graph here. We know the range of this graph here is y more than -4, so we're just going to write that. Y more than -4. So now let's have a look at one last example. We have f of x is another square root function and g of x is a parabola. So first question I'm going to ask you is please work out the expression of fog of x, also known as f of g of x. Pause the video and try this out. And if you had an attempt, we would know that all we have to do is substitute the second function into the first one. So all we're going to do is replace this x over here with x squared. So it just becomes the negative square root of x squared minus 1. Now we know from the previous two examples, this example is not going to help us work out the domain and range of f of g of x. So now my next question to you is, please work out the domain and range of f of g of x. Pause the video and give it a go. Okay, so now let's go through this example. We know that in order to work out the domain and range of f of g of x, we're just going to draw two boxes. And those two boxes will have either f of x or g of x in them. The first box will always contain the second function, the inside function, because that's where all the numbers that we input are going into first. And the second function is the outer function or the output function. Next step, we're going to write the domain and ranges of each of these functions. So the domain and range of g of x is simply a parabola. And we know that the domain of a parabola is all real numbers. And if you wanted to work out the range, we would do it graphically. So I'll help the audience out. We know that a parabola y equals to x squared looks a little something like this. And we know that the only y values that are shown on this graph are the ones where y is more than or equal to 0. So that's what my range is going to be. Y is more than or equal to 0. Next, we're going to do the same thing with f of x. We know that f of x is a square root graph, and just looking at this function here, we know that square roots cannot be less than 0. The inside of the square root must be always more than 0. So, in other words, if the inside of the square root has to be more than 0, then x take 1 has to be more than 0, more than or equal to, sorry. And that means x has to be more than or equal to 1. So that's what our domain is for that function. Next, we're going to have a look at the range of f of x. And again, I'm going to do it graphically. The range of f of x must be worked out using the graph. One way I like to draw square root functions is I like to first draw the square root of x as an example, just to help me out. Then I can use the transformations to work out what has actually been done to f of x. I know that this negative on the outside over here, that means that it's a reflection across the x-axis. So I know my new graph has to look a little something like this, where it's completely reflected. And I also know that because there is a -1 on the inside of the square root, that is a translation in the x-axis. More specifically, it's a translation to the right of the x-axis. So something like this. So I know this is what my new graph looks like, and that's what I need to use. And this coordinate here is 1, 0. Now, the range of this function, as you can see, is it's showing any y value that's going below or equal to 0. And it really helps with the graph, so that's why with a range I always insist you draw a graph. Y is less than or equal to 0. And that's it. We've drawn our number machines, so all we need to do is work out the domain and range of this machine. And again, the way we do this is we need to make sure that all the outputs of the first machine are allowed to enter into the second machine. And I can already find a number that's leaving the first machine, but not able to enter the second one. And that number would be 0. We know that 0 is allowed to leave the first machine, because that fits the range. But we know that only numbers where x is more than or equal to 1 are allowed to actually enter the second machine. So now there's a little dilemma. Poor little 0 can't actually enter the second machine, so we need to change the rules as to what numbers can leave the first machine. So now, all I'm going to say to make that statement true is that the range of g of x is not a subset of the domain of f. And now, because we have an issue, we need to restrict the domain of the first function. And we need to restrict the domain by saying g of x cannot be less than or equal to 1. We want all the outputs of the first machine to match the inputs of the second one. So we want the outputs here to be more than or equal to 1, simply so all those numbers are allowed to enter the second machine. So if g of x is more than or equal to 1, we know that means that x squared has to be more than or equal to 1. X squared has to be more than or equal to 1. And we know, as a graph, if we were to work out what this quadratic inequality would be, we know that y equals to x squared looks a little something like this. And all we're asking ourselves is, when is this function higher than the line y equals to 1? Well, it's going to be higher for x less than this value here, and it's going to be higher than x more than this value here. And we know that when x squared is equal to 1, that x is either -1 or x is 1. So we can simply solve it by saying x has to be less than or equal to -1, or x has to be more than or equal to 1. So that's our new domain. Our new domain is simply this. So now we can say that the domain of f of g of x is x is more than or equal to 1, and x is less than or equal to -1. Now let's talk about the range. Because we changed our new domain to x being less than -1 and x being more than 1, we also changed our range to y being more than or equal to 1. That was the whole goal. Our whole goal was to change the domain so that the range of the first function was y more than 1. And now we need to see if in this allowable domain, are there any numbers that decided to go on holiday and they were just like, nah, let's not go into the machine? Well, no, because the range of the first machine was an exact match, it was the exact same as the domain of the second function, we can say that the range of the entire function f of g of x is just the same as the range of f of x. And so because we're saying this, we know that the range of f of g of x is simply y being more than 0. Y being more than or less than 0.